When dealing with a dwelling unit that has a 200 amp or larger service and utilizes a ground rod, determining the appropriate size of the copper grounding electrode conductor is crucial for safety and compliance with electrical codes. The common misconception is that Article 250.66 directly mandates a 6 American wire gauge copper conductor for such installations. However, this is an oversimplification, and the correct size is actually a 4 American wire gauge copper conductor. To understand why 4 American wire gauge is correct, we must delve into Article 250.66 of the National Electrical Code, NEC, and its specific requirements. Article 250.66 outlines the sizing requirements for grounding electrode conductors. These conductors connect the service equipment, typically the neutral bus in the service panel, to the grounding electrode system. The primary function is to provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. The size of the grounding electrode conductor is generally based on the size of the service entrance conductors. However, there are exceptions and specific rules depending on the type of grounding electrode used. Article 250.66 addresses grounding electrode conductors connected to rod, pipe, or plate electrodes. It states that the grounding electrode conductor shall not be required to be larger than 6 American wire gauge copper wire. This is where the confusion often arises. The critical point is that this limitation applies only to the portion of the grounding electrode conductor that connects to a rod, pipe, or plate electrode. It does not mean that all 200 amp services using ground rods can use 6 American wire gauge wire. The code makes this distinction because a ground rod's ability to dissipate fault current into the earth is limited. Increasing the size of the grounding electrode conductor beyond a certain point does not significantly improve the ground rod's effectiveness in dissipating current. Therefore, the NEC places a limit on the conductor size connected directly to the rod. However, before reaching the ground rod, the grounding electrode conductor must still comply with the general sizing requirements based on the service entrance conductor size. For a 200 amp service, let's consider the typical service entrance conductor sizes. According to NEC Table 310.16, a 200 amp service typically requires conductors with an ampacity of at least 200 amps. Common conductor choices include 4/0 American wire gauge copper or 250 kilo circular mil aluminum. Now, let's refer to NEC Table 250.66 to determine the minimum size of the grounding electrode conductor based on the service entrance conductor size. Table 250.66 correlates the size of the service entrance conductor to the minimum size of the grounding electrode conductor. For 4/0 American wire gauge copper service entrance conductors, Table 250.66 requires a minimum 4 American wire gauge copper grounding electrode conductor. This requirement applies to the entire grounding electrode conductor run from the service equipment to the point where it connects to the ground rod. However, the code allows the portion of the grounding electrode conductor that serves as the connection to the ground rod to be 6 American wire gauge or larger. Thus, you can reduce the grounding electrode conductor to a 6 American wire gauge copper conductor at the point where it connects to the ground rod. In summary, for a 200 amp service with 4/0 American wire gauge copper service entrance conductors, the grounding electrode conductor must be at least 4 American wire gauge copper from the service equipment to the ground rod. You can then reduce it to 6 American wire gauge copper at the connection to the ground rod if you choose to do so. To further clarify, let's consider another example. Suppose the 200 amp service uses 250 kilo circular mil aluminum service entrance conductors. According to Table 250.66, this would still require a minimum 4 American wire gauge copper grounding electrode conductor. Again, this applies to the entire run, with the option to reduce to 6 American wire gauge at the ground rod connection. It's important to note that these are minimum sizes. You are always allowed to use a larger grounding electrode conductor if desired. Using a larger conductor may provide additional mechanical strength or reduce voltage drop in certain situations. However, It is generally not required for ground rods because their dissipation ability is the limiting factor. The requirements for grounding electrode conductors can vary based on the type of grounding electrode system used. Ground rods are just one type. Other common grounding electrodes include metal water pipes, concrete encased electrodes, and ground rings. Each type has its own specific requirements outlined in Article 250 of the NEC. For example, if a metal water pipe is used as a grounding electrode, the grounding electrode conductor must be sized according to Table 250.66 based on the service entrance conductor size, without the reduction allowed for ground rod connections. Similarly, concrete encased electrodes, also known as UFERs, typically require a 4 American wire gauge copper conductor, regardless of the service size, as specified in Article 250.66. C. Ground rings, which are continuous conductors encircling a building, must be at least 2 American wire gauge copper, according to Article 250.66. D. In addition to sizing the grounding electrode conductor correctly, proper installation is crucial. The grounding electrode conductor must be securely connected to both the service equipment and the grounding electrode. Connections must be made using approved methods, such as exothermic welds, listed connectors, or pressure connectors. The grounding electrode conductor must be protected from physical damage. If the conductor is exposed to physical damage, it must be installed in conduit or protected by other means. The NEC provides specific rules for the installation of grounding electrode conductors to ensure their effectiveness and safety. It is also important to ensure that the grounding electrode itself is properly installed. Ground rods must be driven into the earth to a depth of at least 8 feet, according to NEC 250.53. G. The top of the ground rod must be flush with or below ground level, unless it is protected from physical damage. If multiple ground rods are used, they must be spaced at least 6 feet apart. The proper selection and installation of grounding electrodes are critical for providing a low impedance path for fault current and ensuring the safety of the electrical system. The NEC also addresses the use of supplemental grounding electrodes. In many cases, a single grounding electrode, such as a ground rod, may not provide sufficiently low impedance. In these situations, the NEC requires or recommends the use of supplemental grounding electrodes. Supplemental electrodes can include additional ground rods, crown plates, or connections to metal water pipes. The purpose of supplemental electrodes is to reduce the overall impedance of the grounding system and improve its effectiveness in dissipating fault current. When using supplemental electrodes, it is important to follow the NEC requirements for their installation and connection. The NEC also addresses the bonding of metal parts in a building to the grounding system. Bonding is the process of connecting metal parts, such as metal water pipes, metal gas pipes, and metal building frames to the grounding system to create an electrically continuous path. Bonding helps to minimize voltage differences between metal parts and reduce the risk of electric shock. The NEC provides specific rules for bonding metal parts in Article 250. Bonding jumpers must be sized according to Table 250.102. C1 and must be installed in a manner that ensures their effectiveness. In addition to grounding and bonding, the NEC also addresses the requirements for ground fault circuit interrupters, GFCIs. GFCIs are devices that detect small amounts of current leakage to ground and quickly de-energize the circuit. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas to protect people from electric shock. The NEC provides specific rules for the installation and use of GFCIs in Article 210.8. It is important to understand these requirements to ensure that GFCIs are properly installed and functioning correctly. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements for grounding electrode conductors, grounding electrodes, bonding, and GFCIs, you can help to protect people from electric shock and ensure the safe operation of electrical systems. Remember to always consult the latest edition of the NEC and consult with a qualified electrician when working on electrical systems. The NEC is a complex document and it is important to have a thorough understanding of its requirements before performing any electrical work. In summary, when dealing with a 200 amp service in ground rods, remember that while 250.66 allows a 6 American wire gauge connection to the rod itself, the grounding electrode conductor from the service equipment to that connection must be at least 4 American wire gauge copper, based on the service entrance conductor size in NEC Table 250.66. Always prioritize safety and compliance with the latest electrical codes.